Hello everyone, myself Sagar Ramesh Kute, working as Assistant Professor, GMT College, Sinnar, Nasik. Now, last lecture we will discuss Einstein coefficient, and now in this lecture we discussed all example of this first module. First example, find out the population ratio of two states that produce a light beam of wavelength 6943 angstrom in ruby laser and wavelength of beam 6328 angstrom in helium neon laser at a temperature 300, that is Boltzmann constant K is equal to 1.38 into 10 raised to minus 24 joule per Kelvin. Now in this numerical we all given lambda 1 is equal to 6943 angstrom, that is 6943 into 10 raised to minus 10 meter. Now second will be the lambda 2, that is 6328 angstrom is equal to 6328 into 10 raised to minus 10 meter. Temperature will be the given 300. Now calculate N1 upon N2. Formula: the population ratio of two states is N1 upon N2 is equal to E raised to delta E upon KT. Now N1 upon N2 is equal to E raised to HC upon delta T upon KT. N1 upon N2 is equal to E raised to 6.63 into 10 raised to 34 minus 34 into 3 into 10 raised to 8 upon 6943 minus 6328 into 10 raised to minus 10 upon 1.38 into 10 raised to minus 10 raised to minus 23 into 300. Now N1 upon N2 is equal to exponential 0.0324 into 10 raised to minus 16 upon 414 into 10 raised to minus 23. Now solve this and we will N1 upon N2 is equal to E raised to minus 78.1. After solving, N1 upon N2 is equal to 1.2 into 10 raised to minus 34. This will be the answer. Hence, the population ratio of two states that produce a light beam is 1.2 into 10 raised to minus 34. Now, second example. Calculate the wavelength, frequency and energy per pulse of carbon dioxide beam having energy difference between two states as 0.117 electron volt. The laser contains total of 2.5 into 10 raised to 19 atom of element in excited state. Now in this numerical given delta E is equal to 0.117 electron volt, that is 0.117 into 1.6 into 10 raised to minus 19 joule. Now N is equal to 2.5 into 10 raised to 19 atom. Now calculate wavelength, that is lambda, frequency mu and energy per pulse. Formula: the energy relation is E is equal to HC upon lambda. Now first we calculate wavelength of laser. Lambda is equal to HC upon E. Now this formula will be arranged. Lambda is equal to HC upon E. Now put this value HC and E. 6.63 into 10 raised to minus 34 into 3 into 10 raised to 8 upon 0.117 into 1.6 into 10 raised to minus 90. Now solve this equation and we will give the value of lambda, that is 106.25 into 10 raised to minus 7, that is 10.625 micrometer. Now second, we calculate frequency of laser. E is equal to H mu. Mu is equal to E upon H. Now put this value 0.117 into 1.6 into 10 raised to minus 19 upon H value 6.63 into 10 raised to minus 34. Now solve this equation. 0.02823 into 10 raised to 15, that is V is equal to, that is frequency is equal to 2.823 into 10 raised to 13 hertz. Now third we calculate energy per pulse is equal to energy into total number of excited atom, that is energy is equal to 0.117 into 1.6 into 10 raised to minus 19, and the total number of excited atom is 2.5 into 10 raised to minus 19. Solve this equation, we get energy per pulse, that is 0.468 joule. This will be the energy per pulse. Now next example, find out the atomic population at room temperature at first excited level for hydrogen gas having excited energy state 3.39 electron volt. Now in this numerical given, E2 is equal to 3.39 electron volt, that is 3.39 into 1.6 into 10 raised to minus 19 joule. E1 is equal to 13.6 electron volt, that is 13.6 into 1.6 into 10 raised to minus 19 joule. Temperature, that is 27 degrees Celsius, is equal to 300 Kelvin. Now calculate N1 upon N2. Formula, the population ratio of two state is N1 upon N2 is equal to E raised to delta E upon KT. Now put this value, exponential 3.39 minus 13.6 into 1.6 into 10 raised to minus 19 upon 1.38 into 10 raised to minus 20 into temperature 300. Now solve this equation, we get exponential minus 16.336 into 10 raised to minus 19 upon 414 into 10 raised to minus 23. After solving, we get E raised to minus 394.6. N1 upon N2 is equal to 0. Hence population inversion is not possible. Now next example, find out the atomic population at a room at a temperature 6000 Kelvin at a first excited level for hydrogen gas having excited energy 3.39 electron volt. Now in this numerical will be given E2 is equal to 3.39 electron volt, that is 3.39 into 1.6 into 10 raised to 19 joule. E1 is equal to 13.6 electron volt, that is 13.6 into 1.6 into 10 raised to minus 19 joule. Temperature will be the 6000 Kelvin, that is equal to 300 Kelvin. Now we will calculate N1 upon N2. Formula, the population ratio of two state is N1 upon N2 is equal to E raised to delta E upon KT. Now N1 upon N2 is equal to exponential, put this value 3.39 minus 13.6 into 1.6 into 10 raised to minus 19 upon 1.38 into 10 raised to minus 23 into temperature 6000. Now solving, E raised to minus 16.336 into 10 raised to 19 upon 8.28 into 10 raised to minus 20. Now E raised to minus 19.73, that is value of N1 upon N2 is equal to 2.5 into 10 raised to minus 9. Now next example, Calculate the coefficient for stimulated emission if the wavelength of emission radiation is 6300 angstrom, time is 1 microsecond. Now in this numerical we calculate A21. Now in this numerical we will given lambda is equal to 6300 angstrom, that is 6300 into 10 raised to minus 10 meter. Temperature at specific is equal to 1 microsecond is equal to 1 into 10 raised to minus 6, and calculate A21. Formula: Einstein coefficient relation is A21 upon B21 is equal to 8 pi h mu cube upon c cube, but A21 T1 upon temperature at specific and c cube upon mu cube is equal to lambda cube, that is 1 upon temperature at specific B into B21 is equal to 8 pi h mu cube upon c cube is equal to 8 pi h mu cube upon lambda cube. B21 is equal to lambda cube upon 8 pi h mu cube into temperature at specific. Now put this equation, put this value, that is B12 is equal to 6300 into 10 raised to minus 10 cube, that is lambda, upon 8 into pi is value 3.40 into 6.63 into 10 raised to minus 34 into mu 1 cube into temperature at specific value 1 into 10 raised to minus 6. Now calculating this equation, we will value B12 is equal to 1.5 into 10 raised to 19 meter cube joule inverse per second inverse. Hence the coefficient for stimulated emission is 1.5 into 10 raised to minus 19. Now this will be the example of first module. Thank you so much.